Hello everyone, this is episode 5 in the series Scala project from scratch, and this is not the first time I'm recording this video. So I had a recording I made yesterday and it was perfect, it was fine, but accidentally when I was about to start converting the files before editing them, I deleted one of them, and it was the one from the screen with all the sound and so on. So it wasn't, I would need to do quite a lot of work to recover it, so it's just easier to record it again. So yeah, that's gonna have an impact on this episode, but I'll just go through the parts I did again, and hopefully I can also fit in more of that because I already know what I'm going to do. So let's get to it. The last episode was actually quite a while ago, over a month, I think. So you'll have to excuse me for not remembering all that we did here. But the plan for the next episodes was to finally start implementing some real business logic. So our project is actually going to start doing a little more than nothing. So that's what we're going to do. And also, as in the previous episodes, in the beginning, I will go through all the Scala Steward pull requests that were created in the meantime. Sadly, I already went through them. They're already merged in some way, so I can only show you, like, I cannot unmerge them. But I can show you what I did in them, and I think it's going to be informative anyway. So if we look at the git diff from the last episode, we have a bunch of commits. So first of all, I did the Scala update. So I went from Scala 3.10 RC2 to 3.10. This involves updating the Better2String plugin. Nothing extra complicated. It's just that compiler plugins still need to be compiled for every specific Scala version. So in order to support 3.10, I had to release a new version of Better2String, so here we are. Then I forgot to regenerate the GitHub workflow for that. You have to do it, otherwise your CI will fail if you're using SBT GitHub Actions. So I run it again, and the pipeline on GitHub was green. It's still green now. Then we have the HTTP4S upgrade. Nothing specific, nothing interesting here, just a version increase, nothing else. Same goes for SBT native image, SBT CI release, and ScalaFMT. There's actually one more ScalaFMT PR that was opened yesterday, so I'm gonna look at that in a second after we're done with this list. Then also Scala Steward did a formatting run on the whole code base after updating ScalaFMT, so that when it makes a pull request for you with ScalaFMT, we can actually look at that here. ScalaFMT, this one. So when you actually go look at that, you're gonna see these two commits, and one of them is just a formatting run. So if you have enforced formatting in your continuous integration system, it's going to work on a pull request like this. So that was the case here as well. Then we have logback, which was just a version update, and this was probably like a conflict resolution commit. And updating Tapir. And this one was actually more interesting because there are some more changes involved with updating Tapir. So I would like to go through that as well. So first of the changes that I wasn't, actually, let's just look at that commit. So this is 36444. Something like that. Yeah, and that's gonna be easier. Yeah, the endpoint type still exists. It wasn't removed. It isn't why this code has changed, but the endpoint type, the signature changed. So in the past, we only had these 4 types. So we had the input type, the error type, the output type, this is the error output type, the success output type, and some capabilities. So there's a new one in the beginning, and this is the security input. So I think this is a really interesting change, and even though we don't have any security stuff in here yet, maybe we never will, I think it's a valuable change, especially for users who do have some sort of security in their endpoints. Previously, we would do this with some sort of wrappers over endpoints, like custom logic on top of it, and you would end up with quite complex code, like type level computations, in order to separate out the security input from the rest. Or you would have a bunch of boilerplate, like a lot of boilerplate, because you would need to do this yourself with like manually extracting the security inputs. So nowadays, like it's going to be a separate input. I think this could be potentially a really great change for users. So because we don't have a security endpoint, like any security here, we can use public endpoint, which I think I found out about from here. When we look at the security, yeah, so the public endpoint is mentioned here, and this just skips the security input. So this was in client-side executor. I think if we go here, we'll see the definition of endpoint, assuming my code is up to date. And yeah, so public endpoint defines the security input as unit. So that's just it. So that's one good change. Then the HTTP4S client interpreter also no longer takes the string as the base URL. It takes a URI, an HTTP4S URI, which I also think is a change for good, like being more type safe and such stuff. And then in routing, we have more changes. So first of all, server endpoint has also changed, and I think this is the most interesting change in all of these changes in the last version. So server endpoint used to have like 4 type parameters. So the input, the error, the output, I think, and N would be the capabilities here, and F would be the effect. So the first 3 are now type members instead. And there's also the security input. So these are now, input, error, output, and there's also like a new user type for the output of the security input. Interesting. So I don't really know what this does yet, but I guess eventually we'll have we might have some use case for it. So these are now type members, which makes it easier to write code like this and actually, like if I were to do a map on this, now it's going to be much easier to map on like server endpoints with the same type everywhere here than, a bunch of extensions, I guess. So yeah, I welcome this change, and I think it's going to be an improvement for people who like to do this kind of stuff, like put endpoints in a list and transform them somehow together. So yeah, this is nice. It makes for some cleaner code. I like it. And then server logic infallible seems to have been renamed to server logic success. And yeah, then there's just another rename of the endpoint type to public endpoint. And yeah, the same here. Nothing else changed really. So this is it for the change in Tapir. I think these are some really great changes, especially the server endpoint one, and I'm glad it happened. And finally, there's one thing I wanted to change for a while from it, like noticing this in a different project. Using the layout, like the pattern layout, is deprecated nowadays, and you're supposed to use instead an encoder. Like instead of layout, pattern, you just say encoder pattern, and then you put this pattern here. That's all we did. And also I noticed that we only have logback config in the client. We don't have any of this in the server, which could be an issue further down the line. For now, it's probably not so bad, but I would probably like to have some sort of config like this in the server as well. So when we actually start running the server, not just in tests, this would be a good idea to add something like that. Okay, so yeah, this is what happened since episode 4. And yeah, and as mentioned, there was a PR open in Steve from Scala Steward. So let's get that. I think it's just a normal Scala FMT update, just a version bump. So there's a version bump and some formatting changes in SBT. No, that's just okay. So this is a spoiler from the parts of the episode that we haven't, that we don't have. I reverted these changes. So I'm gonna close this, and I'm gonna make this change myself, update to 3.11, and format the whole code base again. So Scala FMT, and let's run Scala FMT in here. Yeah, I'm afraid this was going to, I was afraid it was going to touch the history directory. So .history is my, like I have a plugin in VS Code that does like local history on top of like separately from Git. It also stores like all the changes that I make in my files in case I forget to commit something. I can just remove it for now. I'm not really too worried about the existing state in here. And also the methods directory has like a read-only directory, and then we have the jars for the dependencies. And I think they also include sources, but since these are jars and not folders, not directories, Scala shouldn't touch them. But probably it does. Yeah, it still does. So apparently it still tries to touch jars. So I'm just gonna remove that as well. I think methods will just reload this directory and like rehydrate it again if we need some sort of dependency sources. Like if we go here, yeah, that's again in read-only dependencies. Okay, so we don't really have any changes here. I'm just gonna push that straight away. Okay, and now we can get to the actual content of the video. So, as I said, we are going to implement some real business logic. That's the plan for episode 5, so let me just write it down. Of course, I'm going to be more specific on that. So, let's just have a quick reminder of what this is actually going to do. Basically, we're going to build a fake Docker client, a fake Docker client and server, but we're not actually going to deal with containers. We're going to deal with something called basically just builds. So we're kind of going to have like an interpreter or compiler. It's actually an interpreter. And we'll essentially have two commands, which will be handled by the executor. One of them will take a build definition and return a hash. And then given a hash, we will be able to run it, which basically says, like, show me the system state for that hash. Okay? Now, this is going to have to, like the build action is going to actually store the result of the build somewhere in some like internal storage, so that when we look up the hash, we will retrieve the whole system state. We're not gonna persist the system state in the hash itself. It's not going to be stateless like that, like a JSON web token or something like this. You would also like put data into the token and decode it. We're not gonna do that. We're gonna actually persist the system state in some sort of storage, probably in memory storage for now. But actually, I don't think we're gonna do that today. We'll see. What I wanted to focus on is like building a system state from a build, because we're gonna actually like go build to system state. Then we're gonna take that system state, put it into some DB, and like with some hash, and yeah, basically put that to a DB. This is like super pseudocode. And then given a hash, we should be able to retrieve a system state from the DB. Okay. But we definitely need something that looks like build to system state. Okay. But there's a problem here. Like, I would like this to be as pure as possible. Like, this would ideally just be a description of the process. Kind of like make this, well, a build has a base, right? So this would essentially be like a base to, well, actually something more like a transition, like a list of transitions from a build base to another build base, or from a system state to a system state. This is essentially what a build is. Like, every command in a build is going to be a change to a system state, and a build base would also always be like possible to resolve to a system state, right? A build base can be one of two things. We have the empty image and a reference to some sort of hash. And a hash at this point would be possible to be decoded into a system state. So in essence, both of these will resolve eventually to a system state. And then executing a build would be a matter of like resolving this to a system state and making a list of, well, making a sequence of changes to that system state to result in a new system state. Then we would generate a hash for this, store it, and return the hash again. And this is what the executor is actually going to do, like all of these things. So let's go to the implementation, because this is going to be the server implementation. Okay, here. So here we don't really do any of that. Like the only thing that we could call resolution is like we check if the build is an empty build. We basically resolve whether the base is the empty state, like the empty hash. Sorry, if it's actually the empty image. That's what the empty build is. And we also verify that there are no commands. So I would like to, the goal for today would be to be able to actually come up with a new system state based on the empty image, or based on some sort of system state. Okay. And for this, I think we need a new interface. Like I don't want this to be part of the executor. This could be something separate, something much more fine-grained, something more focused, so that we will be able to test it more separately and have basically more focused tests and a more specific interface, something that's doing just one of these jobs. We'll also do the same for like a resolver, something that will basically take a hash and resolve it to a system state. But for now, I would just forget about state, like, you know, storage, and just deal with system state values and just that. So I would like to call it an interpreter, because it is essentially what it's going to do. And it's going to do like, you know, let's say interpret, not too creative here. And I would like to take a build and return like an effect of a system state. But as I said before, I don't want to deal with resolution here. Like I don't want to resolve what this hash is, right? So instead of a base like this, I think we should just have a system state, but not in the build, because this still needs to support these two cases. By the way, we can now make this an enum. The bug has been fixed in Scala. I don't want to deal with build base, and we cannot rechange this type anymore, not in that way, because we still need to support that. So I'm going to make this like part of the model of the server, and let's call it a model, and let's call this a resolved build. And we're gonna take a base, like a base has to be something. I would say it's a system state, and also a system state might eventually become like an internal type instead of just a. Right now it's a model, like a transport type actually, because it has a codec, a schema. Eventually we could just copy paste this type without these instances, or we can keep reusing the same one. I think for now we can keep reusing it. So we're gonna have a system state and a list of commands, but I also think we should copy the commands. These like this probably makes more sense than copying the system state. Maybe we should copy both. Let's copy this for now. And this is going to be in resolved build. And this is going to refer to resolved build command. And we will skip these two. And now, as I said, we can use enums. Let's do that. So case assert and case delete. These are the two cases that we want to support. Eventually, I think we will want to ensure that this list is not empty, or maybe not. Maybe we'll check that if you try to build a build with no commands, you'll get the same output as originally. And we could do that, like maybe we can use this to create like aliases for existing builds. We'll see later. But for now, I think it's fine to leave it a list. It's going to make the conversion easier. Yeah, so this will not take just a build, it'll take a resolved build. And that's basically it. So I'm gonna create all the other boring part stuff here. Interpreter. Okay. Yeah, exactly something like that. Okay, I'm just going to have something like this, just to let it compile. And now we need an apply method just to be consistent with the rest of the style. I would call it F and make it a given. Okay, so here we have an applicative throw. I think we don't need that. I think just applicative will be good enough because the interpreter doesn't actually deal with resolution. Like here we actually have some failures because in the build part we have some failures if we provide the wrong build, but we are not going to have something like a wrong build in the interpreter. Like I think this will actually never fail, and I'm only leaving an effect here because it might be easier to compose with the rest of the code, but it could very well be just identity, like there wouldn't be any effects here. However, there's an issue with this. So when you run a Docker build as a client, like when you run Docker build some Docker file, you will actually see some progress in the client. And I want to have something like this. We will like artificially slow down the build to be able to see that there is actual incremental progress and that you're not getting just a bunch of data at the end. But I would like to have something like this. So this will probably eventually be something like a stream of maybe system states or like events on a system state. We'll see. But for now, I just want to have a, a smooth, like stateless, pure, transparent conversion. Like, well, not conversion, but transition from a resolved build. So basically from a system state and a bunch of commands to a system state. Okay. And we're gonna implement that in a second. But first I would like to do this kind of separation here. So as I said before, like we need to go from a build to a resolved build somehow. So let's call this resolve event. For now, we'll just put it in here as a private method in the server-side executor. But I think in the end, we will have a separate interface for that and an implementation backed by some storage. And for now, we will only support like the empty image as a base. We will not trust any hash whatsoever. So that this won't really change in functionality. We'll actually just support this one case with the empty base, but we'll also allow some actual commands because this doesn't allow any commands. So resolve with a build, and this will be an F of resolved build. And for this, I think we're gonna steal some of this config, some of this code. It's not config. So if it's an empty build, we'll use not the empty hash here, but the empty system state. So I'm gonna extract it from here. Call it empty system for good measure. And it's going to be system state. And we're gonna use it here again. Okay, so this is a system state, but we need a resolved build. So we'll map on this to go from a system to resolved build system, and I think we can take the build commands and map them to something like resolve command. There we go. Now we'll need to define that. The resolve command is going to take a command. Actually, I'm gonna make it a val. And it's going to go from a build command to a resolve build command. And yeah, pretty much this. Except it's not resolve. Let's just be less creative here. This was upstart, key value, and this is going to be exactly that. And now the other case. There we go. Okay, this warning shouldn't appear here. I think that's like a common metals issue with Scala 3. All right, so I reconnected to Bloop, and that should fix it. All right, so this part seems to be roughly done. We have the resolution, and after resolution, let's do something like resolve build. Yeah, the completions here are reasonable. Like you would probably get a hash from a system state, but that's not a pure, like we cannot do this purely. A system state, like one instance of a system state should always resolve to the same hash, but we're not gonna have like a deterministic algorithm to do it. I will probably do something more random, and I might though. Yeah, we'll see about that, but it's probably not gonna be like a method on the system state. We're probably gonna ask the storage system to return the hash of the system. We'll see. Maybe it's gonna be deterministic, I don't know. We'll see later. So when we have resolved a build, we'll only have a resolved build. And from that, we know that we can go through an executor, an interpreter, like here. And we'll get a system state, but we don't have an executor in scope. I'm gonna add one. Actually, I will put it here, an interpreter. So I like to put like the actual like interfaces that actually do something first, and anything coming from cats effect, I would say these are like very generic, very, it's not going to make so much of a difference if an interface takes an applicative instead of a monad or the opposite. But if something takes an interpreter, I want to know about this when I'm reading the signature of this instance method. You don't have to follow this. Like I would probably say something like interpreter. If we were in a different interface, we were taking an executor, it would also go like as one of the first ones. Then I would say something like logger would go next, or like HTTP backend, or HTTP first client, and then at the end like pipe class constraints. Basically this kind of order. But you can choose your own patterns. So now our code here is going to be fine. It's going to be kind of in compiling state soon, but everyone who's calling us will have a problem because they don't know how to get an interpreter so far. And we're going to deal with that in a second. So I know that I will need flat map, so I need a monad throw instead of just monad. And yeah, let's do it. So flat map. Now we have a resolved build. I think we should be able to say interpreter interpret, even like this. And this is going to be a system state, but we know, we don't really know. I would say that if at this point it's still an empty system state, we can return the empty hash. If it's anything else, we can fail. So something like flatmap, in case empty system. Let's return, empty hash pure. Otherwise, and we can just raise a new throwable. Raise error, f hash. Okay, that did it. I wonder if we can use like named type parameters here. Can I do that? Just specify this one. Oh, the experimental. How do we turn that on? Okay, import. I'm actually gonna do that. And that was named type arguments. Oh, okay. I need a nightly or snapshot version of the compiler. Never mind then. We're not gonna. Well, I thought it was like a stable feature, but apparently it's not. Okay, we're good here. So now you can see some compilation failures like in main and probably another one in the tests. Oops, did I run the wrong thing? No. So there's just one for now. So we can do two things. We could just create the executor here, the interpreter, sorry. Or we could wrap the creation of the interpreter in something that would do both that and just expose an executor. We can do it both ways. I think I'll go for It's hard to say, really. For now, maybe let's do the second thing. So we'll wrap the building of both of these things as part of a server-side executor. So I'm going to call this a module. I'm using a similar pattern in one of my recent talks from, well, earlier this year, I think April or May. It's called Connecting the Dots. I'll put a link in the description. It's on architecture, like in functional applications in Scala. And the idea I'm doing there is like take all the low-level dependencies, like monad throw, like I don't know, like an HTTP first client, things that you would share with everyone else, and then inside your module, like this module definition, instantiate all these algebras, these interfaces, and just return the most high-level thing that you have. I'm only concerned here because if I wanted to share the interpreter with some other components of the server, we might run into trouble because I will need to expose that somehow, so we will not be able to do that and hide the interpreter. But for now, I think we're fine, we can do it. So I'm just going to take a monad throw. This is enough to implement both this and that. And this is going to be an executor given interpreter f is interpreter. These words are so difficult to type. Instance and then instance f. I think that should do it. So now in main, I can use that module instead. And we'll need to go to the server side executor tests. And also we need, okay, that was just an old error. Just call this module. Also, if we do the same trick with like, the same trick of extracting the components, and we define like a resolver interface, and we take it here, we will probably not need monad throw anymore. And we could use things like cats.id. So basically, I think that's the syntax. Is it? Wait. Yeah, basically this kind of type, or sorry, that cat.id. And this is basically, yeah, it's the same type. So it's a type constructor for the identity. ID A equals A, which means that if you have something like this shape, let's say something like that, say foo ID and 1, this just works, and this is just an int, in case you didn't know. So Cats provides that. I don't actually know why we are importing that. Probably just the lack of warnings in Scala 3. Although I think we now have warnings, or we should at least, but probably not on unused imports. Anyway, let's get back to this. Let's just make sure all the tests compile, and let's just make sure they all run. Although I'm pretty sure they will not, because the server-side executor is not going to work right now, because it's using an interpreter that just fails every time and does it in a very explicit way just by not implemented error. We can try running the tests anyway to see how many of them fail. And we will get to a working state very soon. Okay. So for the purpose of these tests, we can actually know that the result build, the base is empty. So if we just return the build base here to f, we should actually pass all the tests, I think. Because the behavior will be consistent with what we saw in the previous implementation. Like once you have confirmed that the build base is empty, like, okay, we're ignoring the fact that the commands are not empty, but we can still pass all the tests. Yeah, but that's not what we're gonna do. Like, we're not gonna leave it at this. So instead, I will create a new file for that. Thank you, method. And we might not need all these imports. I think this one isn't necessary. Applicative is not necessary here. That's basically it. So yeah, so we have a resolved build with some base, that's the system state, and some commands, which I mentioned before, will be kind of transitions from one system state to another. And if I know anything about transitions from one state to another of the same type, this kind of smells like a state monad. And I'm actually gonna use that because I can. So let's define like a conversion from a resolved build command to a state monad. And then I'll show you how we can easily apply all these transitions to a single state, like in a sequence. So this will be like a transition. Actually, let's make it as val. And this is going to be a function from resolved build command to the state monad in cats on the state of system state. System, that's not what I wanted to write. System state and unit. And yeah, let's just not implement that for a moment. I think we haven't covered the state monad yet in this series, so I'm just gonna give a very quick intro. State of S and A is basically a function from like S to S and A. So it's basically given a state, this will tell me how to get to the next state and also produce some output. And the state of system of, with A equals unit is basically like state S unit. It's basically S to S. So running these in a sequence would be essentially just function composition. You just compose a bunch of functions. Like if you had a list of this, like such a list could be converted to a single function like this by just saying like fold left from the identity function and then compose it with something else. But I like to work with like state transitions using the state monad, because if at any point you need something else than unit in the output, all it takes, like you are already there in the monad, you can actually flat map on something like that. So you can have one state transition and use it to define the next state transition. That's how flat map works. So yeah, I think that's pretty nice. So let's implement this. The easiest way, okay, I'm going to show you a couple ways to do this. So first of all, we can take the command and we can define like a state transition. So like state, yeah, basically this. So like new state will be like command match case resolve. But yeah, I'm gonna just work with that. Upsert key value. And what we would do here is we would go with the state and copy it and say state all plus yeah, key to value. Okay, we're missing a brace somewhere. No, okay, we're just okay, I think we're fine now. And eventually, like we'll implement this for the other case as well, but we'll have a new state, which is the system state, and we can return that new state with a unit. That's like the most basic way. Like state.apply, you can think of state just as a case class, and it takes this kind of function, right? This is exactly what we see here. That's the most generic way to define a state instance. Like an implementation of, well, a value of the state monad type. And we'll do the same for the other kind of command. But this is, I'm doing so much stuff inside this. I'm doing like the whole decision on what kind of change I want to make inside this state monad. But we don't need to do that. We already have the command outside of the monad. So we could very well make this transition, like decide on these transitions first. And we can do just that if we just kind of flip the composition of all of this. So I'm going to take this code and put it here on like another level. It's going to be here, like we're going to directly match on this command first thing in the whole function. And we will actually end up with like state monads here. We'll have two possible outcomes. And this would be something like state, state to something like that. We can remove this and state, put it in a tuple. Okay. But, making changes to a state in a way that results with unit is so common that there's a pattern for this. You can just say state modify, and this does the same thing. So just something like that. And here again. So we don't need to return unit together, we just return the new state. Okay, do you still see some like repetition? I do. And also this, like we can remove this whole thing. That's the same behavior. So there is some repetition. Like first of all, we have state modify. Then we take the state, the old state. We make a copy of it. We set a new version of the all property. We take the old version and we make some change to it. So if we wanted, we could make some sort of, like extract some sort of reusable code here. I'm going to use one thing, but I'm not going to actually, define a helper that will do this kind of transition. I want to do something else. So I'm going to actually use lenses for the same thing. And lenses are part of the monocle library. So let's see it. Yeah, always write Scala when you're looking for libraries in Scala. So yeah, there's a new website. So yeah, so this is basically a library that allows you to make immutable changes, on your case classes in a nicer way than with just the copy method. So say you have a nested structure like home, owner, person, and person will be something like this. Yeah, and imagine like you have some sort of nesting, like more nesting than that. And you have one home, let's just, whatever. And you would like to update the name of the owner, right? So you would say something like h1 copy owner equals h1 owner copy name equals, let's say Steve, yeah, sure. So imagine you have to do this, but on like 4 levels. So with Monocle, all you have to do is say like h1 focus owner name set Steve, and this is it. Focus. So this would also compose, like if you had more fields, you would just say like, another field, another field. You can also compose this with like this is the exact same thing here. If you had like a sequence in one of these fields or an option, you can also do that very conveniently, especially in Scala 3. So here we don't really have such a complex case, but I don't really like this like state.copy, state.all, like this kind of thing. I don't really like it. And sure, we can extract a helper, like yeah, basically this like map string to map string, and yeah, make this a state system state unit. Sure, like we could do this and just call the modify function here, like modify with plus key value, but I think I'm going to want the library to be here in some time anyway, and also for educational purposes, I'm just going to add that as well. So we can use Scala search to get the version that's available right now. And that's 310. Let's put it just in the server. And run the import. So in the meantime, I can already start writing this code. So now we're gonna need monocle syntax all. That's the easiest way to import all of that. And I'm gonna say state modify focus all modify plus key to value. Like say what you want, but I think this is cleaner than this. And if at some point we have a more complex system state, it's also going to help us. Like sure, the helper would have been cleaner, no doubt on that. But you know, this is not the only point of the series to have just super clean code. I want to show some more interesting stuff as well. Of course, this is going to be a key. Yeah, I'm just waiting for the import. Oh wait, the import is actually done, but with the indexing. So focus, I think that should resolve now. Yeah, okay, so methods can understand that, and yeah, we're there. But we still don't really run these transitions, right? So I think it's time for that. So we have the build base, and that's the system state that we'll start with. So normally when you have like a sequence of changes to apply to a single value, you would do something like fold, right? You would do build commands fold left and start with the state, and then take like the state, the command, and in this case we would probably do, yeah, something like this. So a transition of the command, run s with the state value. This dot value goes from like a, this would return the eval monad, like eval of system state. I think this is just meant to help you with stack safety, but basically would say dot value to get the value back. However, with state we don't have to, like we can actually simplify this even more. What's wrong here? Oh yeah, we need pure f. So there's a way to make this like even nicer. Instead of a fold left, we can do traverse. I actually have a video about this, traverse with state. I don't remember the title, but you'll see like a card on the video at this point. So we can do traverse, and we can actually just say transition, and then run s build value, and that should be it. So not build, but build base, because we need a system state. Okay. So at this point, the test should still be passing, and what is more, like we could actually start writing tests for the interpreter. Actually, also we don't need this. Okay, so the tests are passing because anytime that we would call this in a test, the commands list would be empty, and we would just return the same state that we got, which is the empty system. And the empty system has an empty hash, so everything works. Okay, so yeah, so we're gonna add some tests, and I was thinking we could do some property tests using munit Scala check. So let me get that. This seems like the right version. Also, I'm gonna pull this up a little and make this a test dependency. Okay, so while this is running, let's just start writing this. So we're in the server tests, and it's gonna be interpreter tests. Not here, but here. There we go. And if I remember well, this is gonna be like a Scala check suite. Yeah. And we'll need an interpreter value, right? So interpreter instance of cat's ID, I think. And because we are using cat's ID, okay, let's just import that. Scala check maybe. I think we're just gonna have to wait for imports for the import and the indexing of the build. Okay, that's not gonna work. Let's try just suite, but like this, munit. Okay, I'm not sure if this is like an uppercase C or not. Almost. Scala check. So we're in the server tests, right? Oh, did it work? It worked. Okay, so now we need an applicator for cat's ID, and in Scala 2 this would just work, but in Scala 3 for some reason we need to import this, so cat's instances for ID. It's kind of confusing. Okay, but this works. I wonder if I can do this. Yep. Okay, So yeah, I mentioned the property test. So let's look at the interface. Okay, so let's actually look at that as well and open it in a new tab. So a resolved build is a SystemState and a list of commands, right? I would say that if we have some sort of state and we run one command, which is the assert command, this should be the same as, I mean, the result of this should contain this key with this value, right? That's not rocket science. I think we can write that down as a test. So basically, like any system plus list assert result has contains the key value combination. And the opposite, like if we have any system plus a delete, and then result doesn't contain the key. So these are just two properties. Let's actually write this first. So I know that we'll need to import, I think, org Scala. Yeah, this exactly. And now we can write the test. So like, wait, this test a property prop. Okay, what if I write this? Wait, this actually like generated the whole test for me? That's nice. Sure, let's do just true for now. And not system, but SystemState. Okay, so we need an arbitrary of SystemState. I'm gonna deliver. So arbitrary is the Scala check type class that defines how to generate a random system state in a kind of deterministic way. And I think the easiest way is to say like generate this map string to string, and then wrap it in system state. And I think there's a helper for this, like arbitrary apply and something like gen. Why is it? Okay, gen arbitrary gen result of system state apply, something like that. So basically you provide a function and it will just say like generate the input and map that to this function. And there's implementations for this for like all arities of the function up to like 22, I think. Or maybe not this high, but I think it's like 6 or 7 at least. So this is an easy way, and it doesn't require any kind of, you know, like a type level magic, Magnolia shapeless and stuff like that. So I think it's nice. Okay, let's see if we can run this. Okay, for some reason Metals tries to format this, like thinks it's difficult to format. I don't know why. Let's try to test the server. Oh, come on. Just stop it. I'm gonna just restart the Metal server because it started to misbehave. And I don't like that. Yeah, it even got unresponsible. So here's some tips for Metals debugging. Okay, it's unresponsible and doesn't even... unresponsive or... Yeah, I think unresponsive is the word. Yeah, it didn't really restart the server because there's no JVM for it. Okay, that's not working, so let's just reload the window. It's gonna start a new server and we'll have to wait for it to turn up. Okay, so Metals is back up. And I hope it won't try to format the file over and over again. Yeah, it seems to be working now. So I want to have a failing test here. And let's run that. Yeah, it definitely failed on like all the inputs. Oh, this is nice. I think that's a really great error message. You get like the code that you need to write to reproduce this issue. because Scala check is kind of, I mean, it's supposed to be deterministic. Like your arbitrary instances are well, should be deterministic, so that if they start, there's actually some kind of state kind of state monad inside there, like in gen. Basically, the function that generates the data, which is somewhere here, like the arbitrary one, the abstract one, to apply. Yeah, something like this. Like it takes a seed basically, and based on the seed, you're supposed to generate the next value and the new seed. So yeah, okay. Anyway, I know exactly why this test failed, because I wanted it to, so that's fine. But instead, let's write what I said here. So yeah, let's just do it ourselves. So interpreter, interpret, results build, with the system and the list upsert key value. We could also say like we want an arbitrary upsert, that would have been fine as well, but I don't really want to generate leaves of an ADT or an enum. So this, when we run that, that's also going to be, let's import result build command, all of them. When we do this, we should get assert equals, we should get a new state, and when we do like all get the key, we should get some with value. Basically this. Let's call this like result. Okay. All right. Actually, I want to refactor this in a different way. This is gonna build the build, and I'm going to inline this result. Yeah, I prefer that. So now it should be fine. It should be succeeding, and it is. So we can do something similar. So like upsert. Like, actually, I'm gonna, yeah, like any system plus upsert, the key system has the given value, and then a new property, any system plus delete, the key is missing. I wonder what GitHub Copilot is gonna say for that. All. Yeah, pretty much it. So when we have a build with like a single command says delete, we're gonna have the key is gonna be missing. Okay. So that's another property. So I have more ideas. So let's say we'll have any system plus upsert key value plus delete the key. This should be the same state and state as system. Like, okay, let's just say upsert. This is the same as just delete. Like if we delete a key that we just wrote, the end result should be the same. But I want to compare like two things. So interpret build all get key, and it should be the same as the system. Is it? No, it's just like interpret like build 2 with just the delete, and yeah, build 2, and the whole values are supposed to be the same. I think that's going to be true. Yeah, okay. Yeah, the formatting is fine. Let's see. We can also make one for like, if we overwrite the thing that we upserted with a different value, then the new value is going to be part of it, or it's going to be equivalent to upserting again once the new value. What I mean by this is, let me just show you. So property upsert, like key 1, okay, key value 1. plus absurd key value 2. It's going to be the same as absurd key value 2. But that's one. Let's just ignore that for now. And I wonder about this. So key 1, value 1, then absurd key 2, value 2. Now this is going to be more tricky because if the key is the same, we cannot like swap these operations in ordering. But we can definitely check that both keys have some value and that key 2 has this exact value. I'm not sure if that's like a useful property test though. So I'm gonna skip it for now, but I have another idea for a good test. We can always add these later. Let's see what it wants to write. Yeah, that looks actually right. So we have one build, like a key value 1, value 2, and just value 2. I think that should be passing. Yeah. Yeah, this is a good bot. Like I don't really have to write these tests. Yeah. Actually, I think this is a good idea to define some sort of DSL for these builds so that we can test it more easily. So something like extension methods on the system state. Let me show you what I mean. Something like extension system state. I think it's wait, it's def. Yeah, something like here. Yeah, I would like this to be like a resolved build. But at the same time, this kind of syntax could be used to work on like actual systems. So I'm not convinced about this. We can probably look at this in a future video. Also, let's remove this. So the last test I wanted to write, and probably the last thing we'll do today at all, is something like this. Ooh, what's that? Let's see what the bot wants to write. So absurd key value, delete the key is the same as delete key. Don't we have that already? Yeah, that's this test. So no need for that. So imagine this, like let me actually write this. That's gonna be easier to explain. So we'll have like interpret, like one, okay. Yeah, I'll come up with a name later. Let me just show the property first. Let's have a system for sure. Then we'll have one list of commands. So build, resolve build command, and more commands. Okay, I know that we cannot generate commands yet, but hear me out. Let's just define an arbitrary for that. And just step it out like that. So the idea I have right now is that if we interpret like system with the first commands, and then we interpret on that with more commands, we'll get the same state as after exactly this, like interpreting the initial system with all the commands. Okay, of course, like the syntax is, this is like pseudocode. Wait, do I have a typo here? No, that's just the suggestions or my typo. I thought it was like a typo in all the interpreter values. So let's try to write this really quick. So like the left hand side is going to be, let's see, interpreter, interpret, resolve build system commands. And then we're gonna do, well, B1, well, sys1. Then we can do interpreter, interpret, So build sys one more commands. That's the left-hand side, and the right-hand side is going to be what's that? Interpret. And okay, yeah, I think it's fine. Interpreter, interpret exactly this, and let's just say assert equals both sides. So now we just need to implement this the arbitrary. Okay, and because this is a union, it's gonna be more difficult, but I think we can take care of that as well. So let me see. Yeah, I think we just need like a one off. That's probably gonna be what we need. On off, and then like gen result of resolve build command upstart, and the same for delete. Gen is easier, like it's much easier than cogen, which is what you would need if this was a function input. Thankfully it's not. What's the problem here? Yeah, so we have all these overloads up to 22. Why doesn't this work? How about apply here? Yeah. So case classes are no longer, like the companion object doesn't no longer gets an apply a conversion. Okay, sorry. A companion object is no longer a function itself. You need to write down like .apply in Scala 3. Or at least it was deprecated in 3.0.0 and now it's gone. I think it was gone already. Let's see if the test would work. This might be wrong. Like I think I have an intuition that it is fine, but and it is. Yeah, cool. Let's see if we can get a name for it. Not like that. Okay. Yeah, let's just write it down. So like split build. Builds the same state as a combined build. Basically this. All of this assumes that none of the commands can fail. Like if any of them could fail, we would be probably in more trouble. But I think the failure on both sides would be the same. Yeah, unless like the failure contained like the index of the command that failed, you know, this kind of details could be more of an issue. Anyway, so we got 1, 2, 3, 5 property tests. We wrote some arbitrary instances, although they are very boring. And yeah, we started doing stuff. Let's just verify that all the other tests work. So we actually got an interpreter algebra, which is already doing some sort of stuff. So if we were able to send a build with some commands, which I think the client should now be able to do, we could, you know, we could actually get a new system state. Although we will never see it because the executor will just fail to return a result. Like it'll just mess, you know, it'll just throw a failure here and return a generic server error because it cannot support like any output system that's not a normal an empty system. Although if we only had like delete commands, or if at least we deleted all the keys by the time that we return a result, I think we'd be fine. Anyway, let's just go through the diff real quick because I need to go very soon. So we added monocle, Scala check, we implemented the interpreter, we defined a module helper for the server-side executor. We split out like the resolution step and the interpretation step. We defined a new result build type for this interpreter, and we wrote some property tests. So that's it. So yeah, so this is all we did in episode 5. I'm going to update the notes here, and yeah, in the next episode, I think we can take another look at these tests. Maybe we'll come up with something more, like some more properties. Maybe we'll start writing like some specific explicit unit tests, just for completeness, and probably some more business logic because that's kind of interesting now. And yeah, so thank you for watching this. As always, leave a like, subscribe, let me know what you liked, what you didn't. Let me know what you would like to see in future episodes. And yeah, I'll see you in the next episode.